last semester, you learned to solve a quadratic equation by factoring. That's first and foremost the best way to go if it factors. That's if it factors. We learned the square root method last class. Square root method was only usable when you had, though, a square term and a constant term. You can't use it when you had a linear term. We learned complete the square. That would probably be my least chosen one, but you'll see before we conclude goal 11 why completing the square is important to learn. Okay? And then the quadratic formula is our next method. And it's literally a formula that you're just going to plug numbers into and work it out. Okay? So, first of all, the equation has to be in this form. ax squared plus or minus bx plus c equals 0, where a and b and c are integers. Please do not try to use the quadratic formula with a and b and or c as fractions. Could you do it? It's possible, but it's complicated, so don't do it. Make sure your a and your b and your c are integers. So it doesn't have to be a 1 here, like it did when we completed the square. Okay? So the a is the coefficient of the quadratic term, the x squared term. The b is the coefficient of the linear or the x term, and the c is the constant term. So that's where these a, b's, and c's mean in this thing right here. Okay? So first you're going to get your equation into the correct form. Then you're just going to plug it in and work it out. Okay? So it's a matter of knowing the formula. So in my let me clear my throat here. In my best voice, which is not very good, okay, I will sing to you the quadratic formula because it's an easy way to remember it. Now there are two forms. I personally prefer Pop Goes the Weasel. You can do Row, Row, Row Your Boat also, but I like Pop Goes the Weasel better, okay? In fact, this was so popular, my song was so popular back when Daniel's sister was in my class. I don't know, how old is she now? 20, so she 6, 7 years ago, okay? When she was in my class, that she brought in a big cookie with the quadratic formula written in icing on the cookie. You'll have to ask her about it. She did. So this is my quadratic formula, okay? So here we go. Negative b plus or minus square root of b squared minus 4ac all over 2a. I'll do it again. Negative b plus or minus square root of b squared minus 4ac all over 2a. 2 years ago, I got mentioned in a tweet, I should say, from someone in college, thanking me for teaching them this song because they remembered it in their college algebra class that they needed. Okay? So, don't just sit and try to memorize. You'll know this. You'll know the formula. It's probably one of those formulas you actually never forget because I just put it to a song. Because you can pull up a song from 8 years ago and probably sing it. If it comes on the radio, you just know it. I don't know, our brains work like that. If I could just sing everything we do, you'd never forget it. Okay, so the formula. Everything just gets plugged in. I don't really care that you list your A, B, and C for me, okay? I'm going to do that at least on this first problem so that you see where I'm getting this from. So again, my A is the coefficient of the x squared term. My b is the coefficient of the linear term, and my c is the constant. With the signs, so don't forget the minuses that are there. That's going to be the sign of the number. And then I plug it in. Now, I will want to see this work. I will want to see this work. Plugged in, worked out. I want to see it on your paper. So I'm going to have negative b plus or minus square root b squared minus 4ac all over 2a. So you're plugging numbers in. Now, you might be thinking, who in the world invented this formula? half of b squared, add to both sides. This is what it ends up looking like. Okay? So if you took this and completed the square, it would look like this. So that's where the formula is derived from. Okay, so let's just work this out now. So I have negative 9 on the outside, which is a positive 9. Square root positive 81 plus 4 times, or negative 4 times positive 5 times negative 2. That's why it's going to be a plus, because I have two negatives. So that's 40 over 10. So I have 9 plus or minus 121 over 10. 121 is a perfect square. That's 11 over 10. And this kind, like the complete the square, the only kind that you will need to finalize the one single little answer. So I'm going to say 9 plus 11, which is 20. 20 over 10 is 2. And then 9 minus 11 is a negative 2. Negative 2 over 10 is a negative 1/5. And those are my values for x. Now, because they came out without radicals, that means at the beginning I could have factored it, which is what I would have done if I was given a choice of how to solve it. If I'm going to solve a quadratic equation, my first choice is factor every time. That would have factored. A lot don't though, which is why we know the quadratic formula. Okay, a question so far? Okay, next example has fractions. Do not work with fractions. Get rid of them. Multiply everything in this equation by the LCD, which is 6, all the way through. So I get 6 times x squared. 6 times 3 halves, 2 cancels, goes into 6 3 times, and I get 9x. Minus 6 times 2/3, 3 cancels, goes into 6 twice, and I get 4, equals 0. And then I'm going to plug it into my quadratic formula. Again, this is my A, this is my B, this is my C. I don't typically write them out. I did that on number 1 just to illustrate for sure you knew what it was. So negative B plus or minus square root B squared minus 4AC all over 2A. So I'm going to have negative 9 plus minus 81 plus 96 over 12. So negative 4 times positive 6 times negative 4, positive 96. So I have negative 9 plus or minus square root 177 over 12. I have no idea. 177 has a square. It does not. 59 times 3, 2 prime numbers, so it does not. That is my answer. Those are my values of x. The variety that I'm showing you, that was a fraction. When I'm showing you varieties that are going to change at the end also, because there are some, well, let's keep going. I tell you, let's just do it. Question on that one? Okay, must be equal to 0. That's important, so subtract that 1. Bring it over to the left side. And then we're going to plug it in. Negative b plus or minus square root b squared minus 4ac all over 2a. So plugging A for A, B for B, C for C. So positive 3 plus minus 9 plus 4 over 2. So 3 plus minus square root 13 over 2. 13 does not have a perfect square or a square factor, so you're done. Gosh darn, I hope I put one of these ones in here that keeps going. Hopefully it's this one. Okay, on this last one I'm going to show you get it equal to 0 first. That's important. So add the 2x and subtract the 5 to make it equal to 0. I like my a positive, so I did bring everything to the left side. So I added my 2, subtracted the 5, so everything's on the left. I like a positive a. It doesn't have to be, but that's the way I like it. So I'm going to plug it in. So negative b plus or minus square root b squared minus 4ac all over 2a. So I have negative 2 plus minus 4 plus 80 over 8. Oh good, does what I want. So I have negative 2 plus minus 84 over 8. 84 is not a perfect square, but contains a perfect square of 4 times 21. So I have negative 2 plus minus 2 square root 21 over 8. And in these kind of questions, it's possible to have the Mickey Mouse. You're not looking at the radical term, just the coefficient parts. And if all numbers are reducible by the same factor, then you reduce it. And they are. They can all reduce by 2. So I'm going to have, for my final answer, negative 1 plus or minus 1 square root 21 over 4. Now, these ones. The 1 in front of the square root 21 would not be necessary to write because that would be understood, but this would not be understood to be there. That negative 1 needs to stay there. So this negative 1 in the front must absolutely be there. This one, optional, doesn't have to be there. So when you square root, look for the possibility of reducing. But remember, you're reducing 3 things. Okay, so we had a little bit of mistakes on those on that assessment we just got back, but some of you only reduced to 2 things. So, okay, a question.